Okay, today we're in lesson 7.4, equations with many solutions or no solutions. 7.4, equations with many solutions or no solutions.
All right, let's take a look at some more equations that look pretty complicated, but really we can undo that complication. Look at this one. Now, first of all, I look at this and say, whoa, look at this. There's variables on both sides. This is looking really, really scary. The thing to do is not to be scared, just to think through it. And remember, if we can combine like terms, that's always going to help us out. So let's look at the left-hand side. Let's look at the right-hand side. Let's not worry about the fact that we have a variable on both sides. Okay, well, let's combine some like terms here. Here I see an x plus 8x. So I have 8 x's, and I add one more x. That's 9x. That plus 4 is just that constant number, so I'll keep it there. And again, I like to check things off to know I dealt with them. So I dealt with those two. I dealt with the 4. Good. I'm all set on the left. On the right, there's not much simplifying I can do here, so it's just 9x plus 4. And now I can want to solve for x. I can subtract 4 from both sides. Okay, so this looks like a nice step. And then here I'm just left with 9x equals 9x. And now I sort of want to bring all the x's to one side. So I guess what I'm going to do is just subtract this 9x from both sides. Let's see what happens. Now watch this. This is sort of fun. Because when I try to bring this 9x over to the other side by subtracting, on this side I get 0. And on this side I get 0. Look what I'm left with. I'm left with 0 equals 0. Well, that's a true statement, 0 equals 0, and you'll notice there's no appearance of x. There's no x equals anymore. And you know what this means? It means that x can be any number at all. What I mean is that this is an example of what's called an identity. It means that this thing will be true for every single number x you try. So you have a number x, your favorite number. If you plug it in here for x everywhere, this is going to be satisfied. And no matter what your favorite number is, this will be satisfied. This is called an identity. It's true for all x. How did we find out that this is really an identity? We tried to solve for x, and we got to a statement that's just true in general. 0 equals 0. That's a true statement, and therefore, since there are no x's here, we see that x can be anything. Pretty cool. Let's try another one. That was sort of a surprising finish. Now here again, this looks like a really complicated linear equation because I see the variable, in this case y, is on both sides. But again, let's just take it slowly and think about what we have. The first thing I'm going to do is distribute that 4 to make sure that it multiplies through by the y and also multiplies the 5. So I'm going to simplify this a little teeny bit, and I'm going to see now 4 times y is 4y, and then 4 times 5 is 20. And that's going to equal, now on this side I can simplify by combining like terms. I see a y, and I'm adding 3 more y's. That's a total of 4y. So I've taken care of those terms. And then I have to still subtract 10. Okay, great. Well, let's bring this 20 to the other side. So I'm going to subtract 20 from both sides. This looks good, right? I'm trying to get my people together on the right side. This is a 0. Here I see a 4y minus 30. Great. And now I'll bring these y's over to this side by subtracting 4y on this side. And I have to do the same thing on this side to keep everything balanced. Let's see what happens here. Well, here I see 4y minus 4y, that's 0. 4y minus 4y, that's 0. And I still have this negative 30. So look at this statement. There are no more y's, and let's just read the statement. The statement is 0 equals negative 30. Well, 0 equals negative 30, we know that's false. That is not true. And so, in fact, really, there are no solutions to this original equation. Because anytime you think you might have a solution, that would lead us to believe that 0 is equal to negative 30, which we know is false. And so, in fact, what we say here is that this is a contradiction. Or you could say that there's no solution to this linear equation. Or if someone really said, well, what's the solution? You would have to say it's the empty set. Any one of those is correct. The point is there are no values that you can insert in for y that would make this identity hold. So this, in fact, is a contradiction. So it's neat. Linear equations might have lots of solutions if in fact we have an identity, or they might have no solutions if in fact it's a contradiction, or we might have one solution. It's pretty neat. But the bottom line is, if we take it carefully, not be scared by having variables on both sides, combine like terms, and do the arithmetic correctly, we're always bound to find out the truth.
Okay, now here we have another type of example from example 1. So far we looked at equations that had unlimited solutions and equations that had no solutions. Now we're going to look at an equation with one solution, which is basically what we've been working on all this year. So we got 4x minus 3 is equal to 2x plus 13. All we want to do is solve for x. Okay? And when they start off, they said add 3 to both sides. So they're going to say, because you want to get the x's by themselves, so they're going to say plus 3 plus 3. All right, now when you combine your 3's, you got a negative 3 and a positive 3. That will go to 0, so they will cancel out. And all you're left with is just 4x on this side. On this side, you got 13 plus 3. That's going to give you 16. Bring down your 2x. And now you have 4x is equal to 2x plus 16. You want all your x's on the same side. So remember the rule I gave you was to move your smaller x. So between 4x and 2x, the smallest one is the 2x. It's positive. So to move it, we're going to subtract 2x from both sides. So minus 2x minus 2x. 4x minus 2x is equal to 2x. 2x minus 2x is equal to 0. So that's gone. So you end up with 2x is equal to 16. All right, you want to get the x by itself. This says 2 times x. So what's the opposite of multiplication? Division. So therefore we divide both sides by 2. So divide by 2 here and divide by 2 there. Not forgetting that whatever you do on one side, you must do also on the other side. So 2 divided by 2 is 1. So I'm left with 1x. Notice I didn't write the 1 down because how many x's do you see? All you see is just 1x. And then 16 divided by 2 is equal to 8. So this is a type of an equation with one solution. All right, you just saw also equations with no solutions, and you also saw equations with infinite or many solutions. Okay, you want to get this in your notes. It's a summary, number of solutions. When you simplify an equation using properties of equality, you will find one of 3 results. Result, x is equal to a. That's like saying one solution. A is equal to a. That's saying infinite many solutions. And A cannot equal B, or A equals B. There is no solution. So there's no solutions there because A does not equal B. A equals A, infinite, and X is equal to a number, or X is equal to A, one solution. Example 2, write a linear equation in one variable that has no solution. So here we want you to write your own equation. Write your own equation that has no solution.
You know, we've been enjoying looking at equations and solving them and getting an answer, or every once in a while getting several answers when we solve equations. I want us to have some fun actually thinking about all of that in reverse. And what I want us to do together is engineer a linear equation in one variable that has one solution. So this is going to be kind of fun. We're going to try to create something, a linear equation, that just has one solution. So, how can you start something like this, thinking backwards? Well, what I'm going to do is I am going to actually write down the answer. If I'm going to do it backwards, I'm going to write the answer. So I'm going to start off with usually how I end. And I say, okay, and so after all that, we see that x equals 4. That's the answer. Isn't that great? Yay! Okay, now what I want us to do is, in some sense, to kind of complicate that a little bit to create a linear equation for which that will be the solution. So we're going to do the kind of steps that we normally do, but I'm going to do them kind of backwards. There's no right answer here. We can just have fun. So the only thing that's important is, if I do something to one side, I got to do the exact same thing to the other. Otherwise, I'm going to lose the equality. All right, so working backwards, I read that. See, that was me working backwards. I thought that was kind of clever. Okay, so how about this? Why don't we just for fun add 3x to both sides? Again, I'm just trying to kind of mess things up a little bit here to camouflage the answer. If I add 3x to both sides, again, if I add to one side, I have to add to the other. On this side, I have 1x plus 3x. That will yield 4x. And on this side, what do I have? I have 4 plus 3x. Those can't be combined because they're not like terms. There's no x's here. Now, already that looks a little bit more complicated than the original thing. But let's throw in some constants. Why don't we just add 5 to both sides? Again, there's no right answer here. You can add 17. You can subtract 54. You can do whatever you want if we're just adding and subtracting the same thing on both sides. So, what do we get here? Well, here I now see 4x plus 5 equals, and now the 4 plus 5 can be added together to see 9 plus 3x. Okay, there, that looks pretty complicated. How about that as our linear equation? So here's a linear equation. So now working backwards, here's the question. So here's the challenge. Solve. And the question that the equation we're supposed to look at is 4x plus 5 equals 9 plus 3x. Okay, so how would we solve this? Well, the first thing I'll do is try to get all the x's to one side. So why don't we just subtract 3x from both sides? And when I do that, what I see here, if I have 4x and someone takes away 3x's, I'm just left with 1x plus 5 equals, and here I have 9, but 3x minus 3x is 0, so I'm just left with 9. And now to undo the addition of the 5, I subtract 5 from both sides. And then what do I see? Well, I see x plus 0, which is just x, and 9 minus 5 is 4. 4. Whoops, 4. Right, 4. Well, notice that's the original thing that we started with. So in fact, this is a linear equation. There's no squares or anything like that. It's a linear equation whose solution is exactly the number that we wanted to have as a solution. So the answer to the question is not x equals 4. That's where we started. This is one of those fun questions where the answer is actually the question. The answer is, what is 4x plus 5 equals 9 plus 3x? That's the answer to the question. What's a linear equation in one variable that has one solution, x equals 4? So, we can actually think backwards, and actually by thinking backwards, I think it helps us when we start to actually move forward, because we realize what we're undoing is nothing more than just trying to take an answer, x equals 4, that's been camouflaged in a very, very complicated way. So now it looks like 4x plus 5 equals 9 plus 3x. It looks really, really complicated, but then when you kind of move through the tundra of the math and the algebra, all of a sudden you see x equals 4. Have fun looking at answers and finding equations for which those are the answers, and I'll see you soon.